Hello there and welcome to another episode of my Isometric RTS Devlog. Today I want to show off the programs in networking that I've made in the last couple of days. Last time we left off, we had a working game lobby, which could be created and connected to from within the game. Over the last days I've expanded upon the functionalities and now the lobby is able to launch a game once all players have indicated that they are indeed ready. This will trigger a countdown mechanism and once that is finished, the game will be launched on all machines. I didn't stop there. If you remember from the previous episode, the way RTS multiplayer works is a bit different from platformers or first-person shooters. This type of RTS has a lot of units and buildings for which it is impossible to synchronize all the data every frame in real time. It will just take too much bandwidth. So in order to achieve multiplayer, every RTS game cheats. It only syncs the commands given and every client has its own simulation of the game world running. The commands are executed in exactly the same order at exactly the same in-game time with a slight delay to allow for the time needed to send, receive, verify and resend commands in the event of failure. This results into an input lag of around 200 milliseconds for every action, which for an RTS game is not that noticeable, but it ensures that the game stays in perfect syncs on every different machine. These simulations are also checked at certain intervals to see if one client's reality has drifted from the other ones by either bugs or cheats. So if it detects that, it will just terminate the multiplayer game, or some more advanced games try to resync the game at that time. If you want to know more about this, I would highly recommend watching the previous episode where I go a little bit more in depth about the subject. So in order for this to work, the starting point on all machines has to be exactly the same. Because remember, I am counting on the game to be set up in such a way that I can rely on the fact that given the same input commands at the same in-game time will lead to exactly the same outcome, always. So let me show you how I solved this with sending as little information as possible. Well, once main is loaded and the splash screen has been shown and the main menu has been shown, the main menu will call all the networking stuff. So if we look into here, the main menu items are created and they are interacted with in this while loop and displayed. If we go here, you can see that when we press on the multiplayer button, it will enter the function do networking, and in do networking first the connection setup screen is shown, and once all the details have been entered in there and the connection is successfully established, the lobby will be shown, and the lobby can return either true or false depending on if an actual game is launched from the lobby or if the escape key is pressed to escape the lobby. If the escape key is pressed, the connection gets disconnected, and if the computer was the host, it will also terminate the server thread, which is started by the connection setup screen if the server is started, if the computer is the host. If not, then the user ID of the player will become its multiplayer ID, so it knows which player is it. Is it player 0 or is it from 0 to 7? And the menu will get closed. Now once the menu gets closed, we will return to our main function, which is here, and there, oh, something went wrong here, somehow this got and in here it will continue to start a clock and set everything up to start the game, set the last connect windows and last actors to get updated, and then it will start to load the game. So if we go into here, it will show the loading screen, create the minimap textures, load the textures, load in the actor templates, load the object templates, set all the default values, load buildings, and then start all the players with basic settings. Then if there is a connection and the computer is not the host, this code will be run, but it's better to first look at the code that the host is running. The host will then continue to load the map and just run through the normal single player loading process, and then once everything is done, it will check the connection, and if it finds a connection, then it will send out the state of all the current map, the current actors, the current buildings, and all the objects in the world. It will do that in one blob, so it will create a new SF packet, and it will say these are the actors, and then it will put the amount of actors in there, and then it will iterate through all the actors and save the X and Y location, the team, and the actor type. And then it will all put that neatly behind each other in the packet, and then when everything is said and done, the packet will be sent to the server, and then the server will basically just relay this packet to every other connected computer, and once this package is received during the loading process, it will say, oh, this is an actor, there are this many actors in there, and then it will iterate through all of them and just start pushing them back into the actor list, and this will automatically also push them onto the map once the actor is created by its creator function. And when it's all said and done, it will put this on true, and then it will continue to wait until the other blobs arrive. The same goes for the building blob and the obstacles. They all basically work in the same manner. Just to be sure, and for support to restore saved games later, I will also insert all the data into the player block, just to create the players in the exact way on every different computer. All the other stats are just automatically calculated on runtime, so the amount of villagers, the amount of swordsmen, the amount of population, the amount of houses that can be supported is all recreated by inserting objects and units, so we don't have to care about that right here. What we do have to care about is the map, because that is randomly generated, of course, and so we have to set every map tile exactly the same, and this just calls the smoothing, so every then it's just for eye candy, so every corner is rendered differently, so that can just be run on every client. We don't have to send those packets around the network. That would be a waste of bandwidth. When everything is said and done and all these conditions are set to true, then the start state is received, and then we can go ahead and continue on our on the other functions, and we just have to run through the rest of the loading process, which is preparing the minimap fog of war, center our view on our villager, and just basically load the base file list for the pathfinding, so it can update that and doesn't have to recreate it every time the pathfinding is run. So that is basically how I sync all the different elements of the game at the beginning of the game. I still have to do sync the clock and make sure the game starts at the same time when all clients are done. So that is the next task I'm going to perform. Thanks for watching, and please don't forget to like and subscribe for future updates.